Okay, this time we're looking at arithmetic sequences, and I have a small sequence set up right here, so we have to figure out what is happening between our sequence. So from 28 to 22 is a subtraction of 6, 22 to 16 is subtraction of 6, and 16 to 10 is a subtraction of 6. So I can pretty confidently tell that we have a pattern here in our sequence. That is to subtract 6 each time. All right, so in our recursive formula, a sub 1, our first term location, is 28. And then we usually see our formula written this way, so we need to add, and all of this, I want to make sure that we understand that this is a sub, that means written underneath, a n sub a sub n minus 1, and then we have what's going on in our pattern, so it's minus 6 is our sequence. All right, let's take a look at what's happening with an explicit formula. All right, so with the explicit formula, we have to figure out pieces to fill this in, and this is a sub 0. Well, we have 1, so this is 1, 2, 3, 4. We have our first location, and we know our pattern is minus 6 when we go this way. So that means when we go this direction, we're doing the opposite, which would be to add 6. So 6 plus 28 is 34. So we already know that that position exists right there. Then we need to know what pattern we found. And so that was negative 6. That goes here, plus n. So I need to finish it off by writing this. So a sub n, man, that really doesn't look like it's down lower. A sub n is negative 6n plus 34. Now, if you were to graph this, because we know it's arithmetic, it's a subtracting or an adding by a constant rate, we know that we would end up with something that was linear. It would be a straight line on our graph, but it would look something like that because we are subtracting 6 each time. We also know that we don't connect our dots because this is a discrete graph, or our points are discrete. And the other piece we know is that there is no long run value, because it's arithmetic. All right, give it a try.